There's nothing new in this video, but the problem you're working on right now brings a couple of things we've seen together, and I wanted to show you that in this little video. You recall that sometimes we have to do a weight calculation before we do work. Sometimes we don't if we're given the weight. We've seen that before. In these problems, in this video, it'll be this kind. You'll be given the weight of the object, and you're called upon to do work. Just use that as your force. Now, if we go into this, let's examine this picture which we're going to use and just understand that in the beginning, this guy's holding this 15 kilogram box over his head. It's got a height of 2 meters. Then he walks up the slope, and when it's done, that box is now higher. It's now here at 3.5 meters. In fact, of course, it's risen upward 1.5 meters. Now you note that I give you the mass of the box here. You won't be surprised to see that the weight is 150 newtons because weight is mass times gravity, right? 15 times 10. We're going to be using that for our work. And using that for something else. He starts here, moves up 1.5 meters. All right, now I wonder if you agree with these two statements. A, which is right here. Since the box has height, it has potential energy. Remember the formula for potential energy? Doesn't the box have height? Of course it does. So that's not going to be zero right there. It's going to have potential energy to start. Now, often we start our problems at zero. Here we're not. He will have potential energy when he starts. B, a statement. Since the box has been lifted, and it is being lifted up, isn't it, by him walking up, work has been done on it. Does that make sense? Sure, force is exerted, and there's a distance. From 2, 3.5, the distance is 1.5, so work is done. Let's do it step by step then. First, in the beginning, it has height, and so the potential energy, which is mgh, is 15 times 10 times the height of 2. It starts out with 300 joules of potential energy. We're not starting from zero this time. Note your code. Here it is. All right, next, he walks up here, doesn't he? And he lifts it another 1.5 meters, doesn't he? He does. We're given the weight here, aren't we? The weight of the box is 150, so we'll use that. That's the weight. I'm not going to go mass times gravity. I'll use the 150. So the work is simply the force times distance. It's the 150 times the 1.5. That's how far it came up, right? From 2 to 3.5. I'll put the 1.5 there, and we'll find out that he did work of 225 joules. Now, the question is, does that work go away? And I hope you're going to say, absolutely not. It does not go away. But where does it go? This guy's being lifted in the air, isn't it? Where does it go? It goes to potential energy, doesn't it? So here's what happens. This object had a beginning potential energy of 300 because it was up in the air already. Then we did that much work on it, 225. And where did that work go? It didn't go into motion. It went into height, didn't it? It went into PE. So we're going to add that 225 of the work here to the initial potential energy of 300. And we're going to have an ending potential energy of 525. I forget, is there another slide? Yes. So we saw two things in this video. First of all, we practiced using weight to find work. We were given the weight of 150 newtons. We used it, found our work. And the second thing is we remembered that that work did not go away. It goes into some kind of energy. In this situation, it lifted the work lifted the object in the air, so it went into potential. Two things. Using work to calculate weight to calculate work, and the work going into potential energy. Bye.